Hello everyone. So today again we'll solve few more questions. So the first one is jump game 1. So in jump game 1 the question is that you are given an array which has some integers. So for each index we have a value that tells us how much steps it can go. For example, in the 0th index we have value 2. It means that from this index we can make a jump of 2 steps. So like in, for example, like one step here and one step to this index. Same way, in index 1 we have 3, so we can jump 1, 2 or 3 steps. So the goal is, given an array with each index giving the number of steps that we can take from that index, we need to identify if we can go from the starting, from if we start from here, can we reach the last index. So for example, in this case, if we take 2 steps, 1, 2, then it says we can go up to 1 step, we go here, and again we can go 1 step, we reach 4, so we reached our end. So we'll return a true. Okay, so there can be different routes. For example, if I take, instead of taking 2 steps and reaching over index 1, index 2, I can directly go to this index where I can have take 3 steps, 1, 2, 3, and I reach. So we just need to return true if we can go from the starting to the end. Now how to solve this problem? To solve this problem, let us assume that our goal is to reach the index 4. Now we'll go from right to left. We'll iterate the array from right to left, and we will try to change our goal value. So if we go one step back, we check whether if from this index, if we add the steps, can we reach our goal. So we are iterating. So initially our goal is the last index value. So our index is initially our goal is length of this particular index. So this length of this array is 5. 5 minus 1 is 4. So 4 is our goal. Index 4 is our goal. Now we check whether when we are iterating from right to left, if we check this position, from this position, that is index of 3 plus this value, can we reach our goal, that is 4. Yes, 3 plus 1 is 4, we can reach. So we can update our goal as this index, that is 3. Then we go one step back. Can we, from this index 0, 1, 2 plus 1, can we reach our goal 3? Yes, we can reach. Then we will go one step back again. From this index, that is 0, 1 plus 3, can we reach the index 3 as index 2? Yes, we can reach. So now our goal becomes this. We can reach from here, we can reach. So this becomes our goal. Then we, from this index, and we reach here. Yes, we can reach. So goal becomes this one. Finally, so we should stop when our goal is equal to the 0th index. So we can finally, once we have iterated and we check whether if goal equal to 0, then we will return true. Okay, so this is how we should solve the jump game 1. Now coming to jump game 2 problem. In this problem, the intention is same, but here, see, again we have the same array. We have, it tells that how much steps you can take from that particular index. Now you should, in this problem, we should return what is the minimum number of steps that is needed to reach the goal. So here we know that from this 0th index we can reach the final 4 using 1, 2 steps, or 1, 2, 3 steps, but ideally we want the minimum number of steps required, so 2 is the answer. So how to solve this? So how do we solve this? So basically what we'll do is we will iterate from the left to right, and we will use 2 pointers. So one which will tell us one is a left pointer and right pointer, which will tell us the range in which we can go from the previous level. So initially we will, the level will be the first index, that is from where we are starting. So from this we can from this level, so the left and right will be 0. You can go from 0 to 0 only from initial level starting. So now from 2, from this index, where you can go max to second index here, or minimum is here. So this is the level, this is the left and right pointer will point this. So this will be a second step, so you can come here or here. So from these two, what is the range where you can go? So we can go till this range. So in this range we are able to reach our destination, that is our goal. So how many levels are there? So we 1, 1 2 levels. So we are at this level, we take 1 2, total 2 levels, so 2 number of steps is required. So how can we solve this? So basically we will initialize a result as 0. We'll have 2 pointer left and right, and then we will iterate until our right pointer. So this will be our left pointer, here we will have the right pointer. Our right pointer is less than or equal to, until our right pointer is less than our target, that is length of n, length of the array -1. Now initially the forest will be 0, then we are iterating from left to right, then we are so we'll every time we are going left to right, so basically we will iterate in the range of, so left to right is controlled by the r till r is less than this, and within this moment we will iterate each level. So in this level we have 2 elements, so we have to iterate till that. So we'll have a for loop for I in the range of left to right plus 1. We check which is forest. So if to I plus that particular index plus the number of steps from that where we can go. So from here we can go to 0 0 plus 2 is 2, so we can come till here. So based on that, so here we have 2 element, right? So if we add index 1 plus 3 1 index 1 plus 3, we can go till here, and index this index 2 plus 1 we can go till index 3. So, but we need to update r with the forest, so we take max here, and we will update the left pointer as r plus 1, r is equal to forest, and we will for whenever we move to the next level we increment the result. Finally we will return the result. Now let's come to the, and yeah, again time complexity of n. Now come, let's solve the next question, that is the stock span problem. So in this question you will be given a list wherein you will have the stock price for each day, and you need to find the span of it. So basically what do you mean by span? So for example, this is the stock price of on each day. The span is basically how many consecutive day uh, this particular number, the stock price was greater than its previous. For example, if we consider 70, so span, initially span will be 1. If it is greater than the previous one, we'll go backward, and if we come here, the span of a stock price is 1 day. In 1 day is the maximum number of consecutive days starting from the day and going backward, for which the stock price is less than or equal to the price of that day. So here we have 70. So initially span is 1. If it is greater than the previous day, now span becomes 2. If it is greater, no, it is not greater. The span of 70 will be 2. Again, if we take 75, it is greater than this 1, it becomes span 2, 3, 4, span is 4. Now if we look into this problem, if we see the span of this is 4, so we know that if this number is greater than this, again this will have a span of 4, so we don't need to compare these elements. Then we will compare 85 with 80 directly. So this is the intention how we can optimize the solution. So what we will do, whenever we see the element first, and we will append it to a stack with price with span as 1. For example, let's say here we saw 100. Initially there was no element in the stack, so we inserted 100 with a span of 1. Next we see 80. We check whether 80 is greater than 100. No, it is not greater, so we'll insert 80 and insert 1. So we'll go to next each step, then we go to 60. 60 again, 60 will be returned and with span 1. Next 70, when 70 will come, so stack while 70 the price is 70, while 70 is greater than the stack top element of stack, so we will pop this element, we will add a span of this to the current result of 1 plus this span is 1, so it becomes 2. Next we will check with 80. No, 80 is greater than 70, so we will append this price 70 with span 2. like this we can solve it. So basically we will create a stack, then we will iterate for each time. The span will start from 1. If the stack is not empty, and the top element is less than the current price, then we will pop that value and the span of that will be added to the current span. Finally we'll append once we have popped all until we find a greater element than this. We will do this popping and adding the result. Finally we'll add the price in the result. Like this way we can solve this problem. Now coming to the two sum problem. Two sum problem is the most commonly seen problem, and like it is the first question that is there in the lead code when you sort based on the number of I think based on easy or frequency, something like that. But yeah, coming to this question, basically you will be given with an array and a k value, a target value, that is 9 here. So you need to find the index of the two elements. On adding them you get the target value. So here you can run it in a double loop of n square time complexity and find the index when index of first one, index of next one. If you add those numbers, if you add the integer value in that indexes, you will get the target value. How to solve it? So what is a better solution, not going O of n square? So basically you can use a hash. So what in Python basically it is a dictionary. So what you can do is you can create a dictionary and you can iterate towards a loop. So first, for example, you see 2, then your target is 9. So if the number is 2, in order to this index, so you need, if you have 2 and there is a 7, then you have an answer for this problem. So you will check whether you have already seen a 7 or not in the index. So we check target minus num is equal to complement. If complement is there in our scene, then we will return. If not, then we will add scene of the current number equal to the index in which it is present. Again, now we will come to 7. Now 7 to 9 minus 7 is 2. 2 we will check whether if complement 2 is in scene. Yes, scene is it is there. So we will return the current index, which is the index of 7, and the index of the complement value 7, scene of 2. 2 we have inserted the 0th index. So we got the answer. So this is the way we can solve two sum problem. Now coming to the three sum problem. The three sum problem on the other hand is nothing but you have a array. You need to find all possible triplets which would give a sum of 0. So we need to tweak this. You can do it in triple loop with O of n cube complexity, but in order to do it in a O of n square complexity, is that you can reduce this problem to a two sum problem. For what we'll do, also there we should not have a duplicate results. Same triplet cannot be given because there is a possibility, right? Here we have -1 so again these can give it duplicate triplets. So we need unique solutions. So first we will sort this array. In order to solve this, we will sort this array and we'll iterate from left to right, and we'll make sure that we are, for example, -1 we are having 2 times, so we will try to process only one time -1 and skip the duplicate ones. And so we will sort it, then we'll go from left to right, and when, for example, when we are at the first value, we will, for example, if this is a sorted one and we are I value is in -1, now we will create two pointer, left and right. The left pointer will point to I plus 1 and right pointer will point to length of array -1. Now while we will run the loop while our left is less than right. Okay, while our left is less than right, we will so if we look into the code, so basically initially we will sort the array, then we will go iterate over the array, and if the array value, if the value is same as the previous value, we will continue because it will be duplicate. We define the left as I plus 1 and right pointer as length of array -1. Now we will continue until our left reach is less than our right pointer. Now we will add all the three ones. So I, the value at I, the value at left pointer, the value at right pointer, and we'll get the sum. We will compare if the sum is greater than 0. If the sum is greater than 0, we need to reduce the sum. If we need to reduce the sum, then we should decrement the R. We need a lesser value So we will decrement the r such that from this side, since it is sorted, we want less number, so we'll decrement r. In case the sum is less, then we need to increase the sum. So we need to increment the L value, left pointer. Else, if nothing, if these two conditions doesn't match, it means that we have already found a triplet. Then we will append this triplet. Then we will increase our left pointer by 1, and we will again try to increment our left pointer until we have not reached. If when after incrementing, our left pointer is pointing to the same integer, if our left pointer is pointing the same value, is having the same value, and left is less than right, then we can keep on incrementing the left pointer. Finally we can return. So this is how we will solve. Next question is the first missing positive integer. So in this problem you will be given an array which can have both positive and negative numbers. You need to find the first the smallest missing positive integer. So in general, what is the smallest positive integer? 1 is the smallest positive integer. In this question, 1 is there, next 2 is there, then what else can be there? If 1 is there, 2 is there, then ideally it will be 3. So 3 is not there. So in this case, if 1 is there, 2 is not there, so 2 is the answer. The simple solution for this, which will make use of O of n space, but simple solution is that you convert this into a set and keep I as 1, while true you will check whether I is there in the set. If I is there in the set, you increment I by 1, else you will return I. So we first start with 1 is there, then I is incremented, 2 is there, 2 is not there, so return 2, like this. Now how to solve this in O of 1 space? O of 1 space is basically, here we use additional space for creating the set, but how to do it in O of n time with O of 1 time complexity, O of 1 space complexity. So for this, what you can do is, since we know that our values, so let's take, if we have an array of 4, maximum possible values, that minimum possible value is we can have, the smallest integer can be 1 and the max value can be 5. Okay, so if 4 is missing, then we can have 5. So the solution will always be in the range of 1 to length of array plus 1. Now whenever we subtract 1 from this, we will always land into any of the index in the array. So what we will do is, we will first convert the array, we'll have first run one loop into the array such that we convert all the negative number into, because we don't care with the negative number, so we will convert the negative number to positive, because our goal is that we want to mark. So when we'll go through the array, for example 3, so 3 minus 1 is 2, 0 1 2, at index 2 we'll mark it as a negative number. So but if it is already negative number, we don't care, right? We have to do something else for that. So what we'll do, whenever we see a negative number, because negative number, if we subtract it, it doesn't contribute to the result. So first we'll convert all the negative numbers to 0, then we will loop through the array and let's see, we will convert all the negative number to 0, then we will loop through the array and we'll get the absolute value. If that value should be in the range of 1 to length, if then we will subtract 1 from that value and check whether what is the value. For example, if we are at this, we get 2 minus 1 is 1, so a of 1 is greater than 0 or not. If it is greater than 0, then we will convert it to negative, marking that we have seen it. And if a of val is a of val minus 1 equal to 0, that means that even 0 means it doesn't contribute to anything, so we will set a of length of array plus 1 into minus 1. Now finally we will we'll run the third loop, which will go through all the element and we will subtract minus 1 and check the minus 1 from that. So basically we are looping through the index 1 to length plus 1, so it will go to length n, and we check if I minus 1 is greater than 0. If it is greater than 0, will return 1. We will return I because we have not visited that index. If nothing is there, then it means that array length of a plus 1 is the missing one. Now coming to the next question, find the row with maximum number of 1s. So basically you will be given you are given an array of m cross n, matrix of m cross n. You need to find which row is having the max number of 1s. So basically you run a double loop. In each loop the number of 1 will start from 0. Then if a of I comma j is equal to 1, then increment the 1. Then finally, once this loop is done, you compare the 1 count with the count in this and update. And in this question we need the answer with the row comma count value. So you can give the row, you can also update the row value. Now next question is the print a matrix in a spiral form. So you are given a matrix, you need to traverse into spiral forms and display. So to solve this problem, what we need to do is we need to use 4 pointers. One is a left pointer, one is a right pointer, and one is a top pointer, and one is a bottom pointer. So we will go from left to right, then right to bottom, bottom to left, then this bottom right to bottom left, then from here to here, and like this. So once we reached here and we are going here, we can reduce, we have traversed this, then top can be reduced. Once we come here and go towards this thing is entirely passed, so we can decrement the right. Yeah, so basically we want to run the loop, we want to perform this operation until our left pointer is less than our right pointer and our top is less than bottom. So initially we want to cover the upper part, then the top to bottom in the left side, then right to left on the bottom, and this one. So there will be 4 loops to perform this, and so we have loop 1, loop 2, loop 3, loop 4. This will be done until at each time we will decrement top. So when we go from here to here, and so we have traversed all the top. So once we have covered everything, so we can decrement the top. So top was here, so basically top here, so it is, we will increment the top. Now it is already covered. Now when we complete this, we were having R here, so we need to decrement top. So once we cover this bottom, if we want to move the bottom towards this direction, so we need to decrement the bottom value. So we are decrementing. Once we complete this, we are trying to so left pointer was here, so we need to increase the left pointer. Okay, so this way we are traversing the entire array, the entire matrix in the spiral form. Okay, so this would take around O of m cross n time complexity.